Alright, so for this last example, there's a little bit more going on. It just combines, you got an integer and a variable, both on the inside and on the outside of the square root. And remember, we call the number that's outside, the term that's outside, we call it a coefficient. The number inside we call the radicand. And so that what we're going to break up is we're going to break up the radicand. And again, just like we talked about in the first two examples, we can break up the 32. In this way to do it, we can break up 32 into a product and then look for what makes perfect squares. And so we'll just keep the coefficient on the outside. We can break up the 32 into 8 times 4. And then the x to the fifth, we can go as x squared times x squared times x. However, if you think about the 8, there's another perfect square kind of folded away inside the 8, which is a 4, because 4 times 2 is 8. So let's break up this term one more time. So we'll just carry it down. We got 3x squared. Let's break the 8 into 2 times 4. So that's what made the 8. And then we have this 4. And then x squared times x. And then from here we can start pulling out the terms. So I'll bring this down again. Rewrite it as 3x squared, and I'm just going to give myself a little bit of room to bring out the terms that are going to come outside the square root, because they're going to end up being perfect squares. So for example, square root of 4 is 2, so that comes outside the square root. Square root of 4 again is 2. Square root of x squared is x, and then you have one more. Sorry, I'm going to have to kind of cram this in there. You have one more x that comes out, and then what's left after the 4 came out, this 4 came out, these x's came out, then you have the 2 and the x that are not perfect squares, so they're going to end up staying inside the square root. So if you go through, I'm just going to kind of rewrite the terms a little bit neater. I got 3x squared times x times 2 times 2, and the square root of 2x. I can combine, so the coefficients, the integers, the 3, the 2, and the 2, they can all multiply. So 3 times 2, 6, times 2 is 12. And then with the variables, since they're all like terms and you're multiplying them, think of this as x to the first and x to the first. So x squared times x to the first times x to the first is going to be 2 plus 1 plus 1, which is 12x to the fourth, and then you have 2x left inside the square root. Similar idea, let's just do it with the factor tree. So we start with 3x squared, square root of 32, x to the fifth. Let's break down the 32 into 8 and 4. And then the x is x times x times x times x times x. And of course we know that each pair of x's is going to come outside the square root and combine. And then you have this x, which is going to end up staying in because that doesn't have a pair. And then let's break down the 8 further into 2 and 4. And so there's the pair of 4's that are going to come out. And then this 2 won't have a pair. So we'll rewrite the 3x squared, that's the coefficient on the outside. The pair of 4's are going to come out. This pair of x's are going to come out. This pair of x's is going to come out. And then what you have left that does not have a pair is the 2 and the x. And then, just like we did in the other one, just like we did in this version of the problem, the integers 3 times 4 is also 12, and over here we did 3 times 2 times 2, which is 12, same thing, 3 times 4 is 12. That's because we didn't break down the 4s into pairs of 2. Makes it a little bit shorter. And then the x squared times x is x to the 4th. And then you're left with 2x. And you get the same thing as the other version.